Hello students, we are going to implement ZCD zero cross detector, PLD positive level detector and NLD negative level detector using inverting and non-inverting Opamp configurations. Opamp stands for operational amplifier, which is an integrated circuit that amplifies the weak electric signal. This is the symbol of the Opamp. Operational amplifier has two inputs and one output. The negative terminal is the inverting input and the positive terminal is the non-inverting input. The basic role of Opamp is to amplify and output the voltage difference between these two inputs. There are two types of Opamp configuration. One is inverting Opamp, where the input signal is fed to the inverting terminal and grounding is done to the non-inverting terminal, and the output will have the phase shift with respect to the input signal. The other one is called the non-inverting Opamp, where the input signal is fed to the non-inverting terminal and grounding is done to the inverting terminal. Here the output will be in phase with respect to the input signal. The components required for this practical is Opamp. The IC pin number is LM741. Function generator. Frequency will be 1 kHz and peak-to-peak voltage will consider 10 volt. Digital storage oscilloscope, where we will consider channel 1 as input waveform and channel 2 as output waveform. DC supply, we will be using +15 to -15 and 5 volt. The pin configuration of LM741 is, it has total 8 pins. The first one is called offset null. Second pin is the inverting input. Third is the non-inverting input. Fourth pin is the minus saturation voltage, that is -V. Fifth is the offset null. Sixth is the output. And seventh is the plus saturation voltage. And eighth is not used. Let's start with zero cross detector. It is also called as voltage comparator, which changes the output voltage from plus Vsat to minus Vsat whenever the input crosses the zero reference voltage. As we can see from the waveform, as the input waveform reaching the zero voltage, the output voltage, it is changing from plus Vsat to minus Vsat. And again, as the input is crossing the zero, the output is changing from minus Vsat to plus Vsat. This is the circuit diagram of inverting zero cross detector, where the input signal is fed to the inverting terminal and it is the pin number 2 of IC741. Third pin, it is given to the ground. Plus Vsat is given to the pin number 7. Minus Vsat is given to the pin number 4 and output is taken across the pin number 6. For practical purpose, we will be considering the input peak-to-peak voltage to be 10 volt, frequency 1 kHz, Vsat to be 15 volt and minus Vsat to be minus 15 volt. Let's implement the circuit and observe the waveforms. This is the Opamp IC. The IC having dot here. From here, the pin number 1 will start. So 1 and 2, second pin, we are giving it with input signal, which is from function generator. Pin number 3 is grounded. Pin number 4, we are giving minus Vset. Pin number 6 is our output. And pin number 7 is the plus Vset. Input is given to channel 1 and output is given to channel 2. As we can see, as the input waveform reaching the 0, the output waveform is changing between plus Vsat to minus Vsat. What we can notice is the input signal and the output signal phase is different. We can see the output is out of phase with respect to the input signal. Now let's see the non-inverting zero cross detector. Here in this circuit, we just need to interchange the pin number 2 and pin number 3 to have non-inverting ZCD. From the waveforms, we can see that the output wave shape is in phase with the input wave shape. So this is the non-inverting ZCD. Let's see the positive level detector where the output voltage changes from Vsat to minus Vsat whenever the input signal crosses the positive V reference voltage. This is the circuit of inverting positive level detector where input signal is fed to the pin number 2 and V reference voltage is given to the non-inverting terminal, that is pin number 3. Here we will consider V reference to be 2 volt. Let's observe the waveform. In this circuit, the positive reference voltage is fed to the pin number 3. Pin number 2 is fed with input signal. Negative of the V reference and negative of the input is connected together. Reference voltage right now is 1 volt. As you can see, whenever the input signal is reaching the 1 volt, our output voltage is changing from Vsat to minus Vsat. Similarly, whenever it is reaching the next 1 volt, the output is changing from minus Vsat to plus Vsat. In this way, this circuit is detecting the positive level voltages. To have non-inverting PLD circuit, we will just interchange the pin number 2 and pin number 3 inputs. As from the waveforms, we can see this circuit is also detecting the positive level voltages, but the only difference is the output wave shape is in phase with the input wave shape. As I am changing the input reference voltages, the positive level voltage detection is also changing between these reference voltages. Let's see the negative level detector where the output voltage changes from plus Vsat to minus Vsat whenever the input signal crosses the minus V reference voltage. This is the circuit of inverting negative level detector where pin number 2 is fed with V input and pin number 3 is fed with minus V reference voltage. Here the V reference voltage will be minus 2 volt. Let's implement the circuit and observe the waveforms. Here the negative V reference is fed to the pin number 3 and positive of the V reference and negative of the input signal are connected together. From the waveform we can see whenever the input signal is crossing the minus V reference voltage, our output is changing from minus Vsat to plus Vsat. The inverting NLD, as we can see, the output wave shape is out of phase with respect to the input signal. For non-inverting NLD circuit, we just need to interchange the pin number 2 and pin number 3. From the waveform we can see the output wave shape is in phase with respect to the input signal. As I am changing the reference voltage, if we observe the output wave shape, the level it is detecting is in the negative portion only. So in this way, this circuit is detecting the negative level voltages.